Bismillahirrahmanirrahim. Okay, well, boys, law of mass action is our today's topic. This law was first of all presented by two independent chemists, that is Guldberg and Peter Waage, in 1864. They proposed this law, and this is called as law of mass action. The statement of the law is that the rate of chemical reaction is directly proportional to the product of the molar concentration of reacting substances. What does this term means? It means that the rate of chemical reaction means the speed of the chemical reaction. Here the term rate means speed. That the speed of chemical reaction is directly proportional to the product of the molar concentration of reacting substances. What does this product mean? Here the product represents you the multiplication term, the mathematical multiplication, and molar concentration, that how many mole of that reactant or product will be formed of the reacting substances. So summing up the statement, it says that speed of the reaction is directly proportional to the reacting substances concentration. Then it depends upon the molar concentration of the reacting substances concentration. Here in this definition, in this statement, this molar concentration term is also known as active mass. In certain books and in certain other notes, you will also find out the term active mass. So active mass means the concentration in mole per decimeter cube. And as we'll proceed to the mathematical term, in mathematical term, the concentration term will be represented by square bracket. Wherever you find the square bracket, that square bracket will represent you the concentration term. Okay, derivation of Kc for a general reaction. Just imagine consider a general reaction in which A reacts with B to form C and D in a reversible reaction. As we have already discussed that a reversible reaction is further consists of forward reaction and a reverse reaction, means the two simultaneous reactions are taking place in the reversible reaction. So in this reversible reaction, the forward reaction is that A reacts with B to form the product, whereas the reverse reaction is that the similar C and D reacts together to form the product. Here in this case the product will be A and B, and here in that case when A and B react together, they will form the product, that is C and D. So we are going to apply law of mass action to both of these reactions, that is the forward reaction and the reverse reaction. So first of all, applying law of mass action to the forward reaction. We have already discussed that what is law of mass action. Law of mass action is the rate of reaction directly proportional to the product of molar concentration of the reacting substances. So here, what is a reacting substance in forward reaction? In forward reaction, the reacting substance are A and B. So rate of forward reaction is directly proportional. Here this R is representing you the rate, F is representing you the forward reaction, is directly proportional to the square bracket is representing you the concentration of the reaction, and A and B are representing you the reacting substances. So rate of reaction is directly proportional to the product of product means multiplication of the concentration of reacting substances, that is A and B. To convert the proportionality sign into equality sign, we are going to introduce a constant, that is the constant will be the Kf. This Kf constant will be the rate constant for a forward reaction. Okay, now applying the law of mass action to the reverse reaction. Here we have already discussed that what is the reverse reaction in that reverse of general reaction. That reverse reaction is the C reacts with D to form the product. So in reverse reaction, the reacting substances are C and D to form the product. Here reverse reaction rate is directly proportional to the concentration of C and D, their product, their multiplication. So to convert this proportionality sign into equality sign, we are going to introduce a constant, that is the Kr. So rate of reverse reaction is equal to Kr, concentration of C into concentration of D. So when chemical reaction take place, we know that after some time equilibrium establishes. When the equilibrium is established, the rate of forward reaction becomes equal to the rate of reverse reaction. And we have already discussed that rate of reverse reaction we represented it with RR, and rate of forward reaction we represented that with RF. So rate of forward reaction is equal to rate of reverse reaction, that is RF equals to RR, by inserting their values into this equation, that is Kf, concentration of A into concentration of B, equals to the Kr, concentration of C into concentration of D. Now rearranging this equation, we are going to adjust all the constants on one side and variables on the other side. So Kf and Kr are the constants. So we are dividing the Kr over Kf. So Kf by Kr equals to the variable C and D. We are dividing the A and B reacting substances on the C and D. So Kf by Kr equals to concentration of C into concentration of D over concentration of A into concentration of B. Here, the ratio of this forward reaction constant and reverse rate constant is equal to the Kc. What is Kc? Kc represents you the equilibrium constant. Equilibrium constant. So by replacing Kf by Kr with Kc, so the new equation will be Kc equals to the concentration of C into concentration of D over concentration of A into concentration of B. This Kc represents you the equilibrium constant. So how we are going to define this equilibrium constant term? This equilibrium constant can be defined as the equilibrium constant Kc is the ratio of the product of the concentration of substance formed at equilibrium to the product of concentration of the reacting substances. Now, just once again imagine that reaction. We have already discussed that A reacts with B in a reversible reaction to form C and D. Here in this reaction, what is formed? The thing formed is C and D, and what is reacting substances? That is A and B. So again, to moving towards the definition of the equilibrium constant, that the equilibrium constant Kc is the ratio of the product of concentration of substance formed. See what is formed here? C and D is formed here, and at equilibrium means equilibrium is already established to the product of concentration of reacting substances. What is reacting substance? A and B is the reacting substance. Each concentration is raised to power equal to the coefficient of that substance in a chemical reaction. See, there are certain chemical reactions in which the number of moles of reactant and product are not equal to one another. So if their number of moles are different from one another, so we have to first balance them, and after balancing, whatever the coefficient comes, we are going to write that coefficient into the power term. So each concentration is raised to the power equals to the coefficient of that substance in a chemical reaction. So writing this equilibrium constant term in more general and general form, that this Kc is equal to the concentration. Oh, there is a mistake. Sorry for that. This Kc is equal to the concentration of product raised to the power of coefficient over concentration of reactant raised to the power of the coefficient. Let's consider a general reaction with different number of moles. So I'm going to consider the general reaction with different number of moles. Here A and B reacts together to form C and D. A mole of A reacts with B mole of B. These small lettered fonts representing us the number of moles of that particular reactant. Number of moles of that particular reactant. So A mole of A reacts with B mole of B in a reversible reaction to form C mole of C and D mole of D. These are the number of moles and they are written in the power term. So again, imagining the same equation, Kc is equal to concentration of C to the power into D over concentration of A into concentration of B raised to the power from equal to the coefficient from balanced chemical equation. These are the coefficient which are obtained from the balanced chemical equation. Thank you boys. If you have any question related to the topic, please WhatsApp me in the group. Thank you boys. Allah Hafiz.